In this session, we are going to discuss about statistics. So, before getting into the topic of statistics, let us know what is statistics and how is it defined. So, statistics systematically collecting the data, analyzing the data, interpretation of the data, and presentation of large numerical data is termed as statistics. So, the collected data has to be studied and interpreted and presented for further analysis, which is termed as statistics. So, statistics is everywhere. In every sector, statistics is being used for their further development, for their future development. We can take examples as industries, education institutions, hospitals, governments use for economical development. Statistics is a very important topic which is useful and which is very much useful in every field to study the further scenario and to analyze the data so that they can make more profits. Statistics is very useful. Now, some of the terminologies which we are going to use in statistics, we have already discussed previously, but just we will rewind them. So, before getting into the main topic of statistics, let us learn certain terminologies which are used in statistics. Fine. What is the first terminology? Data. What is meant by data? Information in the form of numbers or figures collected is known as data, which is also termed as raw data. There is no specific feature how the data is collected. We just collect the data is known as a simple data. Next, the next terminology we use is observations. What are observations? The data which we collect are termed as observations. That means if I take an example, if I am collecting the marks of a class in a single subject, if I take mathematics and if I want to collect the data of max marks of the students, so I have to take the data. So each and every data which is being collected is known as an observation. If a student is getting out of 25, 20 marks is an observation. 16 marks is an observation. 17 marks is an observation. In that way, every information being collected is known as an observation under the data. Next thing, we are going to discuss about frequency. What is an frequency? See, before getting into frequency, we have to understand a small concept called class intervals. So what are class intervals? So before getting into the topic of class intervals and frequency, when a data is very large and we are unable to analyze it without making a tabular column, we make the tabular column using the class intervals. What are class intervals? Class intervals we will discuss further. And now, so in these class intervals, we see certain observations falling into it. If I take an example, how many students have got between 0 to 10 marks? And some students lift their hands. If I get 6 students, that means to say that the frequency of that particular class intervals 0 to 10 marks is 6. That means to say that the students have who got between 0 to 10 is 6. That is known as frequency of that particular class interval. Now, the next terminology is range. What is range? The maximum value minus the minimum value of any given observations is known as range. The maximum value minus minimum value, which we can learn further when we get into the actual class. Next, frequency distribution or frequency table. As I discussed previously, frequencies are used in frequency distribution table. What is a frequency distribution table? A frequency distribution table is analyzing the data, that is presenting the data being collected in an observational process, in a neat process, and arranging in a tabular column using class intervals and frequencies is known as frequency distribution table. To prepare the frequency distribution table, we use class intervals. What are class intervals? Class intervals are the where we have an upper boundary and a lower boundary. That means if I take an example of same thing what I have taken previously, 0 to 10 marks, we see that the students who got between 0 to 10 marks, that is a class interval, lower boundary. For a class interval, we have a lower boundary as well as an upper boundary. In that particular class intervals, if there are 6 to 7 students between 0 to 10, between 10 to 20 there are 7 students. So in this way we prepare frequency distribution table using the class intervals. So class intervals are nothing but where a particular frequency falls into it is known as a class intervals. You can See the definition. Each group in which raw data is classified is called a class interval. What is a raw data? The number of items, observations which we observe is in raw data. That raw data is being interpreted and analyzed into class intervals for further study. That is known as class intervals. So this class interval has a certain size. How to find the size of the class intervals? It is by using the formula upper boundary minus lower boundary. Next, to prepare the class intervals, we have two kinds of class intervals. The first one is inclusive class intervals. The second one is exclusive class intervals. So what is an inclusive class interval? Inclusive class interval is where I said in class intervals there is upper boundary as well as lower boundary. In inclusive class intervals, the upper boundary and the upper limit, which are called as limit in inclusives, the upper limit and the lower limit are not same. Now you can see the example 1 to 10, 11 to 20, 21 to 30, where the lower limits are 1, 11, 21 and the upper limits are 10, 20, 30. They are completely different. That means to say that the upper limit, the lower limit of a class, the upper boundary or upper limit of a class and lower limit of the next class are not same. That is, if I take the upper boundary of 1 to 10 is 10, the lower boundary of the next is 11 to 20. These kind of class intervals are said to be inclusive class intervals. Now, exclusive class intervals. What is an exclusive class interval? Exclusive class intervals are where the upper boundary, now we call them as boundaries, the upper boundary of a class and lower boundary of the next class are same. Inclusive class intervals are converted into exclusive class intervals for easy calculation. Now you can see I have taken class intervals 1 to 10, 11 to 20, 21 to 30, which are known as inclusive class intervals. How can I convert them into exclusive class intervals? I can take the formula upper limit plus lower limit by 2. That is 10 plus 11 by 2. I get it as 10.5. This 10.5 is used for both. In that way, you can see the example and you can understand how can I convert an inclusive class interval to exclusive class interval. Now, under this, we have various topics in statistics. We have discussed in your lower sections, you have discussed about frequency graphs, histograms, frequency polygon, less than cumulative frequency, greater than cumulative frequency. We are going to discuss them in elaborative as we get into our further classes. Before that, let me explain a simple concept clause called as class mark. What is a class mark? Upper boundary plus lower boundary by 2, which is nothing but midpoint of a class interval, is known as class mark. So these are some certain terminologies which we use in statistics. We have defined what is statistics and we have understood the terminologies. So these terminologies we are going to use in our further classes. So let us get to the next concept where we further get into the depth of the topic and try to understand statistics. So what is the next concept we are going to learn? So we are going to learn about central tendency. What is meant by central tendency? Central tendency is nothing but a central measurement. That means the data collected is interpreted, analyzed. So we are going to get a central value for it, a value which is used for further analysis. That particular value is known as central tendency. So for this central tendency, we use three methods to find the central tendency. The first one is arithmetic mean. The second one is mode. The third one is median. So let us get into the first one directly. What is arithmetic mean? So as we get into the topic, we can understand it very clearly. Arithmetic mean. Arithmetic mean is the most common and widely used measurement of central tendency, which is termed as an accurate measurement of central tendency. So let us try to understand. There are various concepts in this which we have to learn one after the other. Arithmetic mean, the first one. What is an arithmetic mean? Arithmetic mean can be defined as sum of the observations by total number of observations. Sum of the observations by total number of observations. We have two kinds of means, mean of an ungrouped data and mean of a grouped data. Now I am going for mean of ungrouped data. If certain observations are given, if I give you the marks of a class, and if I say what is the arithmetic mean, the only thing you have to do is you have to take the marks of all the students, add them, and how many observations you have taken divided by the number. That means x1, x2, so on, xn are the observations, divided by n is total number of observations. This formula is given by summation xi by n. Next comes arithmetic mean. In certain cases, we see that some observations repeat frequently. If I take students who got 25 out of 25, there are 6 students. I cannot write 25 plus 25 plus 25 plus 25. So what do? I write 6 into 25. That is frequency of the 25 is 6. In that way, if we try to measure, we get an arithmetic mean of ungrouped data. The second formula, summation fi into xi by summation fi. That means to say that f1 x1 plus so on fn xn by f1 plus f2. That is the number of observations, total number of observations, and each observation, how many times it is repeating, is taken as an arithmetic mean of repeating frequencies. And to find the arithmetic mean of these repeating frequencies, we can use a tabular column, and I have given the tabular column value, the concepts also, or the tabular column which what we are going to take in tabular columns. First one is class intervals, the second one is the numbers. That means to say that the frequencies, class mark. The main important thing to find the for the ungrouped data, to find the mean is class mark. As we have discussed previously, what is class mark? Class mark is nothing but upper boundary plus lower boundary divided by 2. When you prepare the class intervals, try to go with exclusive class intervals so that it looks easy. Next, after finding the class mark, you are going to get the mid values of the class intervals. You have the frequencies. Then you have to find fi into xi. In this way, we are going to find the we are going to find the arithmetic mean of any ungrouped data. This is the method of finding the mean by ungrouped data. The first formula we have learned is sum of the observations by total number of observations. The second formula we have learned is summation fi into xi by summation fi. Summation fi xi is taken as observation repeating more number of times, and we have a tabular column which we prepare so that we can analyze the data easily. Now we are going to find the next method to find the arithmetic mean. What are the next methods? Next, just try, we have two methods in ungrouped data. Now we'll go for the grouped data. Fine. Now see, mean of grouped data. What is mean of grouped data? In certain cases, we see that the data is very large. We are unable to calculate the data by ungrouped data method, or we are getting a solution bigger values, or we are mistaking ourselves while calculating. So what is that we are going to do? We are going to use the formula which is used for grouped data, arithmetic mean of grouped data. So for this grouped data, the formula is given by a plus summation fi di by summation fi, where di is taken as xi minus a. Di is taken as xi minus a. This di is called deviation method, where a is called the assumed mean. A plus summation fi di by summation fi, di is xi minus a, where xi is the mid value of the class interval of an assumed mean. Wherever you get the highest frequencies of any given class intervals, that particular highest frequencies class intervals mid value is taken as assumed mean. So when we get into the problems, I can explain you well better how to take the value of xi as well as di. Just remember the formula a plus summation fi di by summation fi. Now we are going to go for the next formula which is used for grouped data. The formula which we take is a plus summation fi ui by summation fi into h. Same formula, but there is a little bit of difference. What is ui? Ui is taken as di by h. So what we find for di, we are going to use the same di, but only thing is ui is calculated by di by h. So a plus summation fi ui by summation fi into h. A is same the assumed mean, fi is the frequencies, ui is di by h, that is xi minus a by h. So I have given in explicit and in an easy manner so that you can understand and write down the notes, where and h is known as size of the class interval. In this way, we have four methods to find the arithmetic mean of an grouped data. So we are going to understand them, try to learn them so that we can know what and how to find mean of an ungrouped data as well as mean of an grouped data. Now we are going to go for the next central tendency method, where we can try to understand not only mean, we have other methods also. So we are going to find the next method. What is the next method? Just try to analyze this and try to understand. The next method is known as mode. What is mode? Mode of an data. Mode of an data. If an observation is given, observations are given, The basic method here also we have ungrouped data as well as grouped data. Mode of an ungrouped data is after the observations are given, in the observations, which is the maximum repeating observations. If in a class we check out of 25, 18 is the mark which is repeating most number of times. So 18 is called the mode of an ungrouped data. In this also we have grouped data as well as ungrouped data. Mode of an ungrouped data, highest most frequently repeating term is taken as mode of an ungrouped data. Now mode of an grouped data, for mode of an grouped data, it is a very simple method. The only thing you have to remember is the formula. The formula is mode is equals to L plus F1 minus F0 by 2F minus F0 minus F2 into H. What are F0, F1, F2? I have given you an example. The highest frequency is taken as F1, the above frequency is taken as f0, and the below frequency is taken as f2. So the same thing have to be taken and substituted into the formula, and you'll get the answer. What is L? L is nothing but the lower boundary. So lower boundary of highest frequency class is taken as the L. What is H? H is as usual as in mean size of an class interval. So in this way we are going to find the mode. As I take an example, I can make you well understand, make you understand well better. So for now, just try to understand L plus f1 minus f0 by 2 f1 minus f0 minus f2 into H. This is the formula for grouped data. And what is the formula for grouped data? There is no specific formula. The only thing we are going to do is we have to check which is maximum repeating observation, that is known as mode of an ungrouped data. For grouped data, L plus f1 minus f0 by 2 f1 minus f0 minus f2 into H. And what are f1, f0, f2? I have taken a formula and explain you. I have given the terms abbreviations also. What is L, what is H, f1, f0 and f2? You can understand it well better. So this is a method which is used to find the central tendency. In our next session, we are going to learn about the other method which is known as median, which is also an important method, and how to find the median of a grouped data. Now today in this session we are learned about mean of a ungrouped data, mean of a grouped data, as well as mode of an ungrouped data and mode of a grouped data. So try to take the notes, understand them, so that which is well used for our next session. Thank you.